Hello and welcome everybody. Today we will be talking about congruence of triangle in geometry. So this is where we're going to try to figure out how to prove two triangles or more are going to be congruent to each other without having to show all 6 different characteristics are all congruent. So that is to say, I don't want to show that all 3 sides are congruent and all 3 angles are congruent to show that these 2 triangles are congruent to each other. Now, as below right here, you can see that I have 2 triangles that are going to be congruent to each other according to what's shown right there. You can see that triangle ABC right there is going to be congruent to triangle DPF. So let me go ahead and write that in. Triangle DPF right here on the right hand side. And the reason why I have to make sure that it's very specific is like, DPF and not DFP or FPD, is that each point is supposed to map to another point when you have congruence in triangle. So that is to say, in this picture, you can see how A maps directly to point D. And then you have point P, which maps directly to point B right there, because you can see that their angles are going to be that with the 3 slashes. And also C is going to directly map into F in this case. So yes, again, these 2 triangles are congruent to each other. But what I would like to do is I want to see if there's a way I can, minimize how much I need to show in terms of congruency to show that these 2 triangles are congruent to each other. Now, let's kind of, go up and down the list a little bit if we can. If I only know, like, say, 1 angle out of the 6 things that are congruent, obviously that's not enough, right? If I just know that angle A is congruent to angle D, that's probably not going to work. If I know 2 characteristics, what if I know, like, say, 2 angles are congruent, or a side and an angle that's congruent, or a side and a side that's congruent? Unfortunately, that's still not enough to show that the 2 triangles are congruent to each other, because you definitely cannot draw either of the triangle with only those 2 characteristics. So now when we go to, like, say, 3 of the 6 characteristics, now we have actually something to play with. And that's where you see these guys over here, SAS, ASA, and SSS comes in, because those are the ones that shows congruency in triangles. So let me explain what that means first of all. S means sides, A means angles. So for example, SAS would then mean side, angle, side. So in terms of how that works out is, what I know is that the side of a triangle, right, is congruent to another side in another triangle. Then the angle next to it is going to be congruent to the other angle next to it. And then the side next to that angle is going to be congruent to the side that's congruent to that is next to that other angle. Better yet, why don't we just kind of go ahead and see if we can kind of play with this so you can understand what I'm talking about. So there are a total of 8 cases in terms of, like, trying to possibly show congruency. There is S, side, angle, side, right? There is, how about, let's see, angle, side, angle. There is side, side, angle. Then there is angle, side, side. Then there is also side, side, side. There is also angle, angle, angle. And let's see, am I missing anything else? I do want to say that I am missing a few more. Yes, I am. Angle, angle, side. And then we have side, angle, angle. Okay, so let's go through each case to show you what I actually mean then. The best way I can show that 2 triangles are congruent to each other is the following. Here, you can see what I did was I took out all of the parts of triangle ABC and broke them all out. If I can take if I can take the case that I have over here on the left and build the triangle, then that means that the triangle should be then congruent. So here, let me show you what I mean then. First, let's look at the case of SAS. Okay, so again, what that means is I know a side, and then I know the angle next to it, and then I also know the side that's next to that. The question is, can you then build the same triangle? Well, here, let me give you an illustration of what I mean then. So let's go ahead and take this guy right here, right? That's going to be side AC, as you can see above. Then I'm going to go ahead and take angle A, which is over here, and I'm going to go ahead and put it right next to angle where angle A is supposed to be. Then I'm going to take AB, the side, which is located right here, and I'm going to put it right there. So that right there would be an example of side, angle, side, because all those three are consecutive. Now the question is, can you build the rest of the triangle? And the answer is yes, because if you look at the two endpoints, all I have to do is just connect this part over here, and that's going to be our triangle. So that shows that the triangles, then that shows that we actually have congruency in triangles. If those two triangles have those in common, then that's going to work out then. Okay, so SAS definitely is going to work out. Let's take a different one just to see how that actually works then. Maybe the next one over here, what if I have ASA? So in terms of what that means is just again, like we said, this time around, okay, I'm going to have the angle. So let's go ahead and say I have angle A over here. Then I have AB, which is going to be this segment right here. And I'm going to go ahead and move it next to the angle, just as it says, as angle side. And then afterwards, I need angle B. Well, let's go ahead and take angle B right here. And I'm going to move it next to the end of that side right there. And let me go ahead and move it a little bit closer. And once again, my question to you is, if you have that as your setup, would you be able to then see the rest of your triangle? Or would you be able to build the rest of your triangle? The answer again in this case is yes. Because here you'll notice that at angle A, what I can do is I can keep extending it this way, right? Keep drawing the line like this. And then over here at angle B, I can keep drawing the extended line over here like this. And where the two lines are going to intersect, well, that's where C is. And as you can see, now I've basically constructed my original triangle once again. So in the case of ASA, yeah, that does show congruency in triangle then, okay? Then the next one is going to be SSA. So let's go ahead and talk about that one. Let me go ahead and quickly erase this over here, just so then we can go ahead and use it again. Okay. So let's go ahead and see what I mean by that. Let's go ahead and pull that aside. Here in SSA, what that means is I have a side. So let's go ahead and say AB is the side. I also have the side that's next to it. So that means that CB is going to be over here somewhere. Okay, now be very careful. We actually don't know angle B because, see, we have the two sides, but what that means is that, unfortunately, we don't have the angle in between. So what that means is that side BC right there, I can kind of swing it around all I want because I actually don't know the angle in between. So that means I could put it here, I could put it here, I could put it here, I could put it a whole bunch of different places, okay, because I don't know what is the angle in between. It's not fixed. But anyhow, let me go ahead and erase all of that stuff right there. Okay, and then finally, we know the angle, which one is it? We know the angle that's next to B, and that's going to be C. So I'm going to go ahead and take this guy right here, which is C, and then I'm going to put it at top right here. Okay, so it's a little bit hard to kind of make out, but that's basically what I have right there. Okay, now keep in mind that this angle right here, this angle in between the two sides, we actually don't know what that angle is. So in the end, we actually cannot draw the actual triangle because if we don't know what that angle is, it could be really big, it could be really small, and as a result, we're going to have a different kind of triangle then, right? So one variation might be something like this. We have the same side right here. The angle might be like this, right? And then we know the length of side BC. But then we don't, and then we know the angle of like A, and you can see how that actually doesn't work out then. So unfortunately for SSA right there, that actually doesn't work then. That doesn't show congruency in triangle. For the next one right here, the one that everybody makes fun of, ASS, well, that's actually the same thing as SSA, believe it or not, because you still have a side, you have a consecutive side, and then you have an angle. That's what SSA stands for. In this case, you have an angle and then a side and then a side. Well, that's basically the same thing because you're just putting the angle in the front instead of the end. So if SSA doesn't work, then ASS definitely does not work then. Okay, so let's see. We're moving we're going pretty quickly down the list. I think we have everything we kind of need. Let's see here. Let me go ahead and erase this right here so then that way it doesn't conflict. Okay. Next one, SSS. Okay. So this time around, what that means is we don't know any of the angles. We have only the sides. Well, if I take all the sides and put them together, there's really only one way for us to get a triangle. And in fact, it is that triangle, right? If I gave you a side with length 3, 4, and 5, you can only put it in you can only put it together in one way, and then that one way is always going to be a triangle that is going to be congruent to itself. So it doesn't matter what the angle is. You notice like how wherever you put it, it's always going to lock down the angles. So in the case of SSS, that actually does show congruency in triangles then. Okay. AAA, that means you know all the angles, but you don't know any of the sides. Well, that one, unfortunately, doesn't work, and you can probably guess why. If you know all the angles, you could potentially have a triangle that is way smaller than this one, right? You'll notice that this angle right here could be the same as this one. This angle could be the same as this one. This angle right here could be the same as this one, but those two triangles are definitely not congruent. They are proportional though, meaning that one is like bigger than the other by some sort of proportionality, and that's what we're going to look at in the far future. So we're going to go ahead and cross that out for right now. And finally, for the last case, which is actually the last two cases, well, they're both the same thing because AAS, angle, angle, side, and side, angle, angle, they're kind of the same thing, just like SSA and ASS is the same thing. Do those show congruency in triangles? So let's go ahead and kind of analyze that. So let me go ahead and erase this guy. Erase that small piece, erase the small piece, and small piece over here, and so forth. All right, so let me go ahead and pull this over here. Let's say that we know the side. Let's see, and then we don't know, the next thing that we know is the angle that's next to it. So then that means that we know maybe like say angle A over here. So if I put that guy over here, okay, so that's what it looks like. And in addition, we also know the angle that's next to the angle. Well, that's angle B that's over here. So that's the weird thing because, we don't really know where to put this angle B, so then that way we can draw the triangles. For the time being, we can say that this does not show congruency in triangle, but, if you have dealt with geometry in the past, and this is something that we have to prove in the near future, in a triangle, the sum of the three interior angle adds up to 180 degrees. So what that means is if you know these two angles, then that means you technically know the third. So I can actually have this angle over here, and that now becomes an ASA situation, which basically means that we know we have a congruency in triangle. But nonetheless, unfortunately, we do not have that sum of the interior is equal to 180 yet. So what that means is we're going to go ahead and put this guy right here on hold for the time being. Okay, so they do technically show congruency in triangle, but we're just going to go ahead and put it on hold because we don't have that theorem just for the time being. But there he goes. These are the three things that we have in order to show congruency in triangle. So let's go ahead and see how that actually works out in then some examples over here. Okay, so here are some examples. What I want to do is I want to say, are the two triangles shown going to be congruent to each other? And if so, according to which one of those three? Is it going to be SSS? Is it going to be SAS? Or is it going to be ASA? So let's take a look at the first example. Here in the first example, you have triangle ABC, and then you also have triangle ADC. Now note that AD is congruent to BC because of those dashes to indicate they're the same. We also have AB is congruent to CD, so because those dashes are the same. Now that means that we have two of the sides that are congruent, so I can definitely eliminate ASA in this case, right? And the last thing that I'm noticing, which is not written, is that AC is congruent to itself because it is a shared side. So what that means is, I guess if I want, I can kind of put a triple dash over there. But right there, yeah, we can now say that those two triangles are congruent. Triangle ABC is congruent to CDA, because I got to make sure that they match, like in terms of mapping, it by the reason of SSS, because all three sides in both triangles are exactly the same because they are congruent to each other. Okay. All right, let's look at the second example over here. Okay. Here you can see that FI is congruent to GIs, which is good. So we have one side. We have EI is congruent to HI, so that one is good too. Now, again, it's going to be most likely an SSS or an SAS situation. So the hidden part for this problem, you might see it already, is that you have this angle right here. These two are supposed to be congruent to each other because of vertical angles. So now that I've put the mark in there, you can probably say, yeah, those two triangles are going to be congruent. So in conclusion, in this case, triangle FIE is going to be congruent to triangle GIH. And the reason for that is by SAS, because you can see how we have a side, then we have the angle, and then we have the side, right? They all have to be consecutive to each other. All right, keep going. A few more examples. Here in this third one over here, you can see what's given. Let's see, we have two angles that are going to be the same. We have two sides that are going to be the same. And then do they have something that is hidden that is not given? The answer is yes, definitely. We have KM right here, which is going to be congruent to itself because it is shared from both of the triangles. Now, unfortunately, in this case, if you look at what's given, right, this is going to be a SSA situation because, look, you have a consecutive side, and then you have the angle next to the last side. And then on the bottom triangle, we have a side, we have an angle, we have a side. So that right there, unfortunately, doesn't work because the top is showing SSA, but whereas the bottom is showing SAS. Yes, the order actually matters when you put the S and the A. So in the conclusion right here, these two triangles are not congruent then because you're not showing the same SSS, ASA, or the SSS, SAS in both triangles. Okay, so they're not congruent to each other. All right, and then the other example over here, looking at what we have, you can see that we have this angle right here, N, is congruent to this angle S over here. We have NP is congruent to QS right here. And then finally, this angle is congruent to this angle. So if I were to kind of write it just like I did in the previous problem, we have an angle, side, angle, right? Because they're all consecutive and next to each other. Over here, we have angle, side, angle. So yes, these two triangles are going to be congruent to each other. ONP, the triangle, is congruent to triangle RSQ. Okay, and the reason for that is by ASA. All right, and finally, here's the last example for this one. Here you can, let's see, we can kind of like write, well, everything is all drawn out for you. So maybe we can go ahead and draw the S's and the A just to see what's happening here. Here we have an angle. Here we have the next consecutive angle. And then we have the side over here. Then we have the corresponding angle to T, looks like it's going to be W. And then the corresponding angle to V is going to be X right here. So that's going to be an angle. Oops, sorry, this should be an A right here. And then after that, it looks like you have the side that's next to it, which is going to be UV is congruent to XY. So in this last case right here, yes, the two triangles are congruent because of what we said earlier, right? Remember, if you know the two angles, you definitely know the third side, assuming that you know that it adds up to 180 degrees. But because unfortunately we don't, we're just going to go ahead and quote unquote put this on mystery for the time being. So we're going to say that this is an AAS situation, which we're going to say, for right now, we don't know if it shows congruency in triangle. All right, thank you so much for watching. I will see you.